Hi guys. Good morning to everyone in Tanzania. Welcome to our last week, actually, of coding. Of class. Yeah, we're gonna go ahead and get started. We're gonna be going over a lot of problems today. Yeah, without further ado, we'll go ahead and get started with the problems. And I'm pretty sure the first person to go today is going to be Claire. Yeah.
Okay, first of all, is everyone logged into CodeQuest? Um, I'll send you guys a link just in case. Um, I'll just post the link in the Q&A channel, and it's just the CodeQuest. So make sure you guys are logged in, and I guess let me know when you guys are all ready. Okay, so I hope you guys are logged in by now, and I'll start sharing my screen. Um, okay, can everyone see my screen? All right. So the problems I'm going to go over today are data lockdown, detecting multipaction, so until donor sort. So these four problems. So head on down to these problems and we'll start with data lockdown. So if we look at the problem description, this is just the problem background, basically saying that a lot of companies put effort into making sure that their information is kept secure. This is just the problem background. If you guys want to read it, you can. But the important part is the problem description. So here it says that we're working with Lockheed Martin's Enterprise Business Services to monitor internet traffic by Lockheed employees. Then the proxy Lockheed uses maintains a log showing what website someone is trying to access and how much data is being sent in their request. Small requests are normal. Internet browsers have to send websites a small amount of data to let them know what they want to see. However, very large requests can be an indication that someone is trying to upload a file to an external website, which could be a data breach, which is something we don't want. So what we're trying to do is to make a tool that's going to automatically flag these requests for like big, um, big, big amounts of data for additional review. And the proxy logs will indicate the website being accessed and the amount of data being transferred in the request. So requests to Lockheed Martin's websites, which all end with a .lmco.com, can be ignored. However, any request to another website that transfers more than a megabyte, so 1,000 kilobytes of data, should be reviewed. Okay, so our sample input is going to look like this, where we have the first number is the amount of records in the log, so basically the amount of test cases. And then 6 lines is going to be how many basically of these lines we're going to have. So how many websites we're going to have, along with the amounts of data that's being accessed. So um, what we want to do is basically flag the websites that have more than 1,000 um, kilobytes being like sent. So in this case, you can see that there's these three websites that are sending more than 1,000 kilobytes of data. Except the catch is that any website that ends in a .lmco.com can be ignored. So in this case, since this website, even though it's sending more than 1,000, since it ends in a .lmco.com, we can just ignore it. So our code is basically supposed to ignore this ending while flagging all the websites that have more than 1,000 kilobytes being sent. So our sample output is just going to print the entire line of the website link along with the number of kilobytes that's being sent, so amount of data. Okay, so now let's start coding. So I'm going to be using Replit, and what we're gonna start with is import sys so that we can basically access the data that's being inputted. And then since the input is going to look like this, we know that we have like a number at top, which is going to give us the number of test cases. So this number is going to tell us how many times we basically need to repeat our code. So what I'm going to do is put a big for loop around our entire code. So first, obviously, I need to get the number. So I'm going to do the number of cases is equal to int because we want an integer value. Sys.string dot read line. And basically, this is going to give us the first line of our input. Okay. So now that we have that first number, I'm going to make that big for loop, like I said. So for I in range, then cases, because that's our number. Okay, so now we have a for loop. And then, oh gosh. And then if we look back at our input, we see that we have another number here. So this is going to give us the amount of lines. So we need another for loop for that. And to make another for loop, we need to get another number. So for this, I'm just going to call the number maybe like sub cases. So just sub for now. And then again, we want an integer. And then again, it's going to be system.standard input dot read line. And that's going to be our number for another for loop, because again, we're going to be iterating through every single line of these. And since they give us the number 6, we know that there's 6 lines, and so we want to be going through each of the 6 lines. So we have this for loop here. We're going to be writing another for loop for that purpose. So again, let's do for k this time, range sub. Since these are nested for loops, we can't have these variables be the same, which is why I'm using I and k, so different values. Okay, and then now we can actually start writing our code to process this information. So now that we have this, what we want to get is the next line. So we want to get that next line of input. I guess these are actual links. Okay. So we want to get that next line of input. So I'm just going to set a variable line equal to this dot this. And This time we're not putting the int around anything because what we want is a string. We want the entire line, and this part isn't an integer anyway, so we would have gotten like an error. So for here, I'm just leaving it as is because this is just going to give me a string anyways. And then what I want to do is basically split these inputs. So I want the link separately and I want the number separately because if I keep it together, there's no way I can process, like, there's no way I can just get the number. So what I'm going to do here is split the string so that we have the link on one side and then the number on the other. So I'm just going to do like array, even though it's not actually an array, then line.split. So what this is going to do, since I haven't like have a specific thing to split by, it's just going to split by default by like spaces. And that's perfect for us because here between the link and the number is a single space. So if we just split it by the spaces, then we're going to get an array or a list with the link in one and then the number on the other. But right now, both values are set as strings. So that's fine for the link. So I'm just going to have that as like web. And that's going to be the first element for array because again, it comes first. So this is going to be index of 0, and then the number is going to have index of 1. So since all the elements in the list are going to be strings, that's perfect because the link should be a string. But for the number that we want, so I'm just going to do number, it has to be an integer. So we're going to put the int around it, basically to cast the string to integer type. So again, it's array index 1 because the number is going to be the second element in the array, and Python indexing starts at 0. Okay, so now we have all the variables initialized, and so now we can actually go through and check the string and the number for all the criteria that we need. So first, I'm going to check if there's the .lmco.com, so that way we can just like ignore the number. So if and then l.lmco.com in web. That's basically going to check if we have this string in the string web, so the link that we already saved. And then if this is true, then we can just continue. And then if not, and we can continue because we're skipping it. And if not, so if number is greater than 1000, then we can actually print out the entire line. So print web, num, and this comma just puts the space back so that we have in our output, we have that space there. Because if we miss a space or we have an extra space, CodeQuest is going to mark that as wrong. So for our code here, that's all there is. And let's actually try it. So I'm just going to copy the sample input and then run and then paste. And then, okay. So the sample input ended here. And since we didn't have like an extra like enter after it, our code just started printing here. So we can just pretend that there was like an extra space here. And our output is going to be these two. And if we check with the sample output, we'll see that we get the same. So we get the Dropbox 1424, which is the same as here. And then the Australia and 4120. And it's all the same. So our code works. And then we can basically just save this now. So if we go here, go to the main.py, and then click the three dots, and then download. Then if we go back to code quest and then we submit our solution, and then here just basically choose your file. So we choose it and then we click upload solution, and then it might take a while. So if we refresh, we'll get solved. So this was the code for data lockdown. And if you guys have any questions, again, put them in the Q&A channel, and then we'll just keep going. So we did data lockdown, and then now we have detecting multipaction. So if we look at the problem description, again, this is the problem background. If you guys want to read it, you can. But here's the description. So let's see. Lockheed Martin Space Systems is working on a new communication satellite system that includes an array of RF antennas. And if you want to know what RF is, you can read the background. Your customer is concerned about the risk of multipaction events. Again, if you want to know what all these are, you can read the background. And basically, what we're trying to do is detect these multipaction events. So here, they give an explanation as to what a multipaction event is. So basically, you've noticed during testing that a multipaction event results in abnormally high readings in both the phase null and third harmonic channels. Basically, the phase null and third harmonic channels are going to be two lines of input. So one line is going to be phase null and one line is going to be the third harmonic. And basically, if in both of these channels, um, if the readings are between 60% and 85% of their maximum power input, then we get a multipaction event. So, in other words, if for a given time index, both channels show a power reading between zero point 0.6 and 0.85, that indicates an event that should be reported. So, if we look at our sample input, so down here, again, we have like the number of test cases. And then basically each test case is going to be two lines. So this is one test case, this is another test case, and then this is the third test case, which is why our number here is 3. So basically what the problem is asking for is if there is a time index. So basically, if we look at these two lines and we look at them by like columns, so by up and down, if both of the numbers in each column is greater than zero point 0.6 and less than or greater than or equal to zero point 0.6 and less than or equal to 0.85, then we need to like report that. So for example, if we look here, we have these two. So it would be, since index starts at 0, it would be 0, 1, 2, 3, 4. So index 4, we have these two numbers that are greater than zero point 0.6 and less than 0.85. So then in this case, we would have to be reporting this index. So 0, 1, 2, 3, 4, so index 4. Similarly, we could go through every single one, and that's basically what our program is going to do. So if we look at the sample output, oh, okay. So for this one, oh yeah, we also have this example of the event that we need to report because it's over 0.6 and less than 0.85, and same for this one. So for the first test case, we would have to be reporting index 1 and index 4. So the way we format our answer is going to be how many events there are, and then this multipaction events were detected at time indices, then colon, and then a space separated list of the index followed by a period. And then if you only have one, then you would have a multiplication event was detected at time index and then the index number followed by a period. And then if there's none, then we just print no multiplication events detected. So if we start to program that, I'll delete this. And then again, you want to start by importing this so that we can read our input. And then again, since our sample input shows the number at the very top, we want that number so that we know how many times we want to loop our code. So let's get the number. Again, I'm going to call it cases. And then again, we want an integer value. Then just read the line. And then we make the for loop. So for I in range, then cases. And then, so the way I'm going to approach this problem is we're going to start with an empty string. So it's going to be called index. And then what we're basically going to do is every time we find these events, we're going to add the index to the string. And then in the end, we'll just print that out. So we'll see. You'll see how this goes. So we have the string index. And then we also want a count variable so that we know which one of these to print. So I'm just going to have count equals 0 for now. And then, um, as you said, the first row is the, the phase null. And then the second row is the third harmonic channel. So I'm just going to name that by calling the first line phase. And then what I'm going to do is read the line and then basically get rid of the um the spaces and then split it. Um, or I could just split it just to make things simpler. And then basically that's going to take the line and split it by spaces, just like we did in the previous problem. And then we have the third harmonic channel thing. And then we do the same thing. We're going to take the line and then we're going to split it. Okay. And then now um, what we want to do is go through every single like one of these numbers and basically compare it with the corresponding index for um, the other one. So I'm going to go through the first one and then the first list, and then we're going to have to look at the same index for the third list or the list named third. So I'm going to make another loop, another for loop to go through this first list. So in range and then length of this list so that we go through the list. And then here is the if statement. So if, and then we want the float because again, these values are floats. So float, then that the element of the list. And if this is greater than or equal to zero point 0.6 on and uh, that number is also uh, less than or equal to 0.85. Wait. So if these, okay, okay, parentheses. And also, we also want to make sure that the second array, the corresponding values are also in between 0.6 and 0.85. So we can do and float third at that index value is greater than or equal to zero point 0.6 and float, yeah, is less than or equal to 0.85. Oops. Okay. Mm, okay. So we have some parentheses problems here. Let's go through. Oh, okay. So um, all right. Hmm, okay. Let's just keep going. So if that is true, that means we basically have that multiplication event. Um, and so we can add to the index string. So plus equals and then a space because what I want to do is add that space at the beginning, like at the beginning of every number. So add that space and then also add k because again, k is that index of the list that we're going through. So that's it for index. And then again, we want to add one to count because we have one more multiplication event. That's all for the if statement. So now let's actually use like this count and index. So we're going to be now focusing on the printing part here. So if we have if count is greater than 1, then we can print and then so let's see. When count is bigger than 1, we want the count. So print count. And we also have like this string here. So what I'm just going to do is copy and paste this. And then space and then that string there. Again, I just copy and pasted from the sample output just so that I don't have any like typos. And then what you want to do now is print the index string because it's going to have all the spaces and the number and the spaces that we want. So print the index string, and then finally we want a period because that's how it was in the sample output. And then now if count equals 1, then we print, and then let's go back to here so we can copy and paste it again. So like that. Make sure you don't get the space here because again, in the index string, we already added the space. So now we can just copy all that over and yeah, okay. And then we add the index, then we add a period. Yep. And then finally, we can just put else because if it doesn't satisfy all of this, then that means the count is 0. So then we can just print, um, and I'll just copy that over, just so there's no typo. Then no multiplication events detected. Okay, so that was kind of a long one. Um, Again, if you guys have questions, you can ask them in the Q&A channel. But let's try this out just to make sure it works. So let's just copy in the code. Oops. Okay, so there was a parentheses thing here. Um, that's, okay, let's try that. Hmm. Um, okay. Okay, now that works. So I'm just going to clear the console so you can see this better and then paste. Okay, so again, our output ends at 9.2. So basically, our input ends at 9.2. So basically, this entire thing is our output. So if we check with this, okay, I forgot the elif. Okay, make sure your if statements are right, guys, or else you're going to get like this extra no multiplication events detected. Okay, so let's run this again and paste it again. Okay, so now this is our output, and if we check it with the sample output, we get all the right answers. Two multiplication events detected, an extra space there, and then a multiplication event was detected at index 5, and then the last one is no multiplication events detected. Okay, so now if we save this, and then we go here, and then you can download the file. Then if we go back to CodeQuest, we can submit our solution. So I believe it's this one. Okay, then we upload the solution, and then we refresh, then we keep up. Okay, try that again. Okay, and then we keep refreshing, and then we get solved. Sorry, I clicked on the wrong file the first time. Okay, so that was the answer to the detecting multiplication. Again, if you guys have any questions, you can put them in the Discord. And then let's go back to the problems. And then we did these two, so discovering planets is next. Okay, so if you read the description, um, basically the background is like we have a planet that's just been discovered, and we want to kind of characterize the planet. So we have temperature, presence of water, survivable surface. So, like, it's talking about magnetic fields here. And then we have how circular or how non circular an orbit is. And basically, what we want to do is see if the planet is considered habitable. So, uh, okay, so if you look at the sample input, let me zoom in here, it's going to look like this. Again, we have the number of cases. So this is just going to be something that's always in CodeQuest. And then we have these four lines, which represents the four um, cases. And each line is going to have four things. So the first is a float that has the average temperature. Um, and then the second thing is a Boolean that indicates the presence or absence of water. And then the third thing is the presence or absence of a magnetic field. And then the last thing is another float between 0 and 1, which represents how circular or non circular the orbit is. And so if we go down here, we have all the criteria that the planet needs to meet. So um, if the planet's temperature, again, the very first value is over 100, then print the planet is too hot. Otherwise, if it's too cold, so if it's below 0, then print the planet is too cold. Otherwise, if the planet doesn't have water, so if the second boolean or the second value is false, then we print the planet has no water. If the planet doesn't have a magnetic field, then we print the planet has no magnetic field. And if the last number is greater than zero point 0.6, then we have to print the planet's orbit is not ideal. And if all of these basically all of these criteria are not met. So basically, all of these criteria are to see if the planet is not habitable. So if the planet is not habitable, then we print the planet is habitable. So this is a big chain of if else statements. So because as you can see, there's a lot of ifs in the problem itself. So now if we start programming, um, I'll delete this. Okay, so again, first thing, we want to import this so that we can read the input. And then again, we want to get the cases. So cases is the integer of the first input. And then we're going to make a for loop just so we know how many times to iterate through this to get every single line. Colon. And then again, I'm going to make like a list for all of these. And then, so what I'm going to do is make a variable line, or no, list equals the next line, and then we split it so that we get every single element on its own. And then now all we need to do is basically like define all of these four variables. So the first one was temperature, and then this is going to be a float value. So float, then the first, oops, not array list. And then the next one is water. So water, and then this is a boolean. Um, or we can just leave it as a string. And then this is the second element. And then the next one was the field, if there is a magnetic field or not. Then this is just the next value. And then the last one was the eccentricity, or whether it's a circle or not. So I'm just going to call that ECC for eccentricity. And then this is going to be a float. And then it's the fourth element. Okay, so now we can begin the if statements. So I'm just going to go through the order that it's put here. So if the temperature is greater than 10, or 100, sorry, then we print, and then again, I'll just copy it over. Um, actually, no. The planet is too hot. And then, oops, and then if or else, if the temperature is less than 0, then we print the planet is too cold. And then else if water equals false, since again we saved it as a string and not as a boolean, so I can just use it as a string here. Then we print the planet has no water. Then else if the field equals false, then we print the, the planet has no magnetic field. And again, I'm getting all of these from the problem itself because it told us what to print out here. And then in our last condition is if the eccentricity is greater than 0.6. So basically the eccentricity is a number that determines like whether an ellipse is a more circular or more oval shaped. But if that is greater than 6, then we print the planet's orbit is not ideal. And then finally, if all that is not true, then our planet is habitable, and then we can print the planet is habitable. Okay, so let's test this again. Um, just copy that here, and I'll clear that. Yes. Again, our output is starting from here. So if we check it with the sample output, you get habitable, it's too cold, there's no water, and the orbit is not ideal, which matches all the stuff here. So if we go back to CodeQuest, we can submit. Oh, I forgot to save. So save the problem and or save the program to your computer, and then we can go to CodeQuest and upload that file. And then let's see if it works. Okay, so that came back right away and we got solved. Okay. And then finally, we have donor sort. So let's look at this problem. Um, okay, so the problem description. Oh, okay, so the background is that a local charity has hired you to help organize their list of donors. The organization has a list of people who donated last year and this year. And then we want to split that into three groups of people. So people who donated last year but not this year, people who donated both years, so last year and this year, and then people who donated this year but not last year. So we need to separate these three groups, and our input is going to look like this. So each case is going to have two lines. The first line is last year's donors, and then the second line is this year's donors. And so, what we want to do is basically separate the people who are only in this one, only in the second one, and then that are in the people that are in both of these. So, we need to separate this. So, our output is going to look like this. So, we have the first line, which is people who gave last year but not this year. And then this second one is for both. So, both last year and this year. And then this last line is for the people who gave this year but not last year. Okay. Oh, and each list of names should be sorted alphabetically. So if we go to Replit, yeah, I'm going to keep the import sys because we need that again. Okay. So cases, again, is going to be int and then the line. We don't need the R strip. We can just leave it as is. And then we go for I in range and then cases, just to make that big for loop again. And then what I'm going to do is basically just get these two lines separately. So I'm just going to do line 1 equals, or yeah, line 1 equals the line dot split. And then this time we're going to specify what to split by, because instead of spaces, we have commas. So split comma, and then line 2 is the same thing, split at the comma. Okay, and then um, I'm going to make, okay, so now what I'm going to do is make like a list, list 1 equals blank for now, and then list 3 equals blank. So what I'm going to do is basically go through these two lists. And then for the ones that overlap, I'm going to put that in list 3. But what I'm going to do is basically for this array, what I'm going to use it for is to see which ones are only in the first line. And then for the second line, I'm not going to make a new list. I'm just going to remove the ones that overlap with the first line. So if I continue here, what I'm going to do is loop through this first line. So for string or for yeah, for string in line one. So basically it's going to go through every element that's in line one. And if basically k is equal to or in line two, it's checking for or if string is in line two, which is checking for if this element that's in line one is also in line two. Then what I'm going to do is put it in the list three or list three because list three, as I said, for this program is going to be the um, the collection of names that's in both line one and line two. So list three dot append and then a or string. And then what I said about like the removing and adding stuff, since the two lines overlap at this element string, what I'm going to do is keep it in um, line one, like not change line one because we're going to go through line one. And what I'm going to do is get rid of it in line two because the two of them have this string in both of them anyway. So I'm just going to get rid of it in one of them. So what I'm going to do is go to line two, and then dot remove, and then the this variable string, and then else. Um, so if this string is only in line one and not in line two, then I'm gonna put that in this list one. And yeah, so again, I'm not touching line one because I'm going through line one. And if you're going through something that's also simultaneously changing, you're either going to get an error or you're going to miss a couple elements. So that's why I'm going through like this. Or you could go backwards, but for me personally, I just find this to be easier. And so now what we want to do is print it all. So we want to print everything. And for okay, for this, I'm going to make a new method because we also need to order them alphabetically, like order all the names alphabetically. And instead of going through each list one by one, I just think it would be easier to make a single um, a single method to do all of that for us. So I'm going to make a method and I'm going to call it output. And then the input that we want is this list. So I'm going to just call the input list. And then first of all, what we want to do is sort the list in alphabetical order. And Python actually has a method for that, so we can just do sort. Pretty simple. And then I'm going to have a string called answer that we can just add everything to. And then for I in list, so we're going to go through the list, answer plus equals the I. And then when we output it, you see that we want the commas there. So I'm going to put a comma there. And then be careful to not just use this because if you just print this, we're going to have a comma at the end. So what I'm going to do is just print everything in the line or everything in the answer from 0 until that second to last point. So that -1 is going to tell the program that print the the string, we're going to stop at the second to last one, which means we're not going to print the comma. And so if we try this, I'm going to just copy that over. And if we paste that, oh, oops, I forgot to actually call the method. All right, so now we just call the method 3 different times on this one and this three. And then again, we didn't change the line 2. Like we didn't make a separate list for that. So I can just print line 2. And the reason why I'm printing them in this order is because the problem said so. Line 1 for us is going to be this line. So it's the names of last year's donors. And then line 2 is the list of um, this year's donors. And so in the output, it wanted us to do last year and then both years and then this year. So that would be last year and then both years, because I just had that as list 3. And then this year, which is line 2. Okay, so now if we try run this, should, oops, oops. Okay, one thing to note for Replit, you can't use Control V, so you have to right click and paste. So, oh, oh gosh, okay. Um, okay, so if we compare our answers, let's see. Okay, so if we compare our answers, we can clearly see that something's not right. So let's see what went wrong. All right. Mm, okay. So in this case, we needed that R strip because when we got it from the inputs, I guess it put in the like the enter as well. So we got like a random enter in the middle. But now our answers match up because it's here. And if we look at the answers, the sample output, then we can see that they match up. Okay. So let's save that code and then download it and then go back to CodeQuest. And then we can submit our final solution. And then we get solved. Okay, so those are the 4 problems that's all for the problems that I'm going to go over. Again, if you guys have questions, please leave the questions in the Q&A chat and leave the, um, okay, then the next person will present more problems. Okay.
All right, so I'll be going over the next 4 problems. So give me just a quick second to share my screen and we'll get started. Okay, so the first problem we'll be going over is brick house. So let's read over the descriptions. Okay. So basically we're trying to build a brick house literally. And the problem background, yeah, we're using small and big block or large blocks or bricks, sorry, to create like this little like structure. And the program will be given a goal length for the brick wall and the number of small and large bricks available. Small bricks are each 1 inch long, large bricks are 5 inches long, and you will need to determine if it is possible to build a row of bricks exactly as long as the goal using only the available bricks. And the sample input is so the first integer represents the number of small 1 inch long bricks, and the second integer, so like these over here, represents the number of large 5 inch long bricks. And the last one is the target length of the wall. So yeah, that's basically the problem, and let's try coding this out. So I have here opened Replit, and I'll start by defining the three things that we need. So I'll just say def brick house, and I'll say small, large, and goal for the goal length. And inside, what I need to do is I need to try to use up all the large bricks first. So in order to do that, I'll name that variable as max. So max is going to be equal to goal. And since the larger blocks are 5 inches long, then I'll need to divide that by 5. Okay, so that's going to be my first conditional. And second one is uh I'm gonna set up another variable that's gonna say we cannot use more large blocks than what we already have. So that's gonna be I'll name this since we already have large, I'll say L bricks for large bricks, and I'll say minimum, and then we have the max and then the large. So what that's gonna do is that's gonna say, oh, we cannot use more large bricks than we already have. Okay. And next thing, the next conditional I'll use is um, so whatever remaining blocks we have, then I'll calculate how many bricks we have left after we take out the large blocks we used. So I'll name that remaining. So remaining equals and then goal and then minus, and then since the large blocks are 5 inches long, I'll again say L bricks and then multiply that 5. Okay, and that's going to be my next variable. And then after that, I'll have a return statement, and we'll say if we have enough small bricks to cover the remaining length, then we can build that wall. So I'll say return, and then I'll say if we have enough small um, that is equal to the remaining, or we have more than the remaining, then we can use that. Just like that. Okay. So that's gonna be my first like I guess like variables that I'll be using. And after that, I'll do the um like the input statement. So I'll just say n equals int and then input. That way we'll be able to input our own values to test our test cases. And after that, I'm gonna do a for loop to run through the number of test cases we have. So I'll say for in range and then n, and then I'll say the next inside will read through the small, large, and goal values. So I'll say small. It kind of says it here, but small goal equals, and then I'm going to be using the map function, which is going to read through all the test cases. So this is faster than looping through all of it. So I think the map function will be a lot more efficient here. And then I'll say int input, and we'll split them. Like that. Okay. So how this is going to work is up here we had all of these conditions, and we basically are going to run through all the test cases we put in through all of this, and we're going to split each of these values. So small split, large split, and goal. So we can calculate them individually. And the next thing is we're going to see if it is actually possible to build this wall. So the best way we can do this is probably by using an if statement. So let's say if, and then we have this statement. So we'll say if brick house, and then small, large goal again. I'll just, and if it is possible, then we're gonna print true, obviously, and then if not, then we're gonna print false. So, and then we'll just use the classic if else statement. So if else, then that's gonna print false. Okay. And I think we have covered everything in the code. Let me just indent this here. Yeah, so let's try running this. And so yeah, so it did compile first, so that's a good sign. And I'll just get all the sample inputs. I'll just copy it in here. And so yeah, so all of these cases ran and we have the true, false, true that we needed. Yeah, so it's a pretty fairly simple code, I think. Let's download this and let's see if it works in our code or in the code quest. Okay, submit your solution. I have main py, here you go. And then upload solution. Let's see if everything we did was correct. So judging in progress, and I think if I refresh it, then yeah. Yeah, so we did do this problem correctly. Okay. So that's all for Brick House. The next thing, oh, I think I got logged out. Never mind. Okay. Next problem will be by the book. Um, yeah, here it is. Okay. So, for by the book, here is the problem background. So just to give you a quick summary, on the back of the books you read, there's something called the ISBN number. It's like a 10 or like 13 digit code that lets you know. It's like a basically an ID for the book. It's used to identify the book. And so the problem description is some Lockheed Martin sites maintain a library of technical books for employees to check out. This helps employees learn about technologies they may not be familiar with. Unfortunately, your site suffered a fire recently, and you volunteered to help assess the damage and try to recover the collection. The library has a collection of books with labels that were damaged in the fire. Some has already attempted to restore the ISBN numbers on these labels, but it quickly became apparent that not all of the numbers are correct. You have been asked to write a program that can read in ISBN numbers from these labels and determine if the numbers are valid or invalid. And books with invalid ISBNs will be set aside to be manually researched and corrected. And this is kind of giving us the formula we need to calculate or to check the digits of the ISBN numbers. So in this case, we are checking an ISBN with 10 digits. So to calculate the check digit of an ISBN 10, each of the first 9 digits is multiplied by an integer weight, a number calculated by subtracting the index of the digit from 10. These products are then added together to form a single number. The check digit is the number that must be added to the sum to reach a multiple of 11. So if that number is 10, the check digit is the letter X. So um, it kind of looks complicated, but really, what this is saying is we're going to start from zero, obviously, because that is going to be our index where we start with. And this is just kind of the formula they gave us. So all of this I just read, it really boils down to this formula. And then this is kind of like a test they did over here. And they determined like this was the final sum of it. So the weighted sum of this ISBN is therefore 130, and 130 is not divisible by 11. And the next highest multiple is 132. So 132 divided by 11 is going to be 12. So that will be the next highest multiple. And since 132 minus 130 is 2, then the check digit for this ISBN should be 2. So the check digit is basically how many numbers you're off from the multiple of 11. So the number has to be divisible by 11. And this will match the last digit in the ISBN we're investigating. So this ISBN number is valid. So the first line of the program's input is received from the standard input channel. So again, like last time, we'll be using the like the input method, and that will contain a positive integer representing the number of test cases. And each test case will include a single line containing an ISBN 10 number to be checked. And ISBNs can include numeric digits and the uppercase letter X. So it's not we're not just checking for digits or like numbers, but we are also are going to be considering the letter X. Okay, and the sample output is just supposed to say valid, invalid, things like that. So true, false, same thing. But let's code this out. So let me just clear this over here. Um, and first I'll start by saying def, and I'll name this by the book, by the book, and I'll say ISBN, and and I'll say if len ISBN is does not equal to 10, then that will return false. So again, it cannot be sorry, it cannot be false, or sorry, it cannot be equal to 10. Always has to be a multiple of 11. So in this case, it will return false. So that's the first thing we checked for. And next, we're gonna calculate the sum of the first 9 digits. So I'll start by saying that the total is equal to 0. So that's just gonna be our starting like number. And for I, and then I'm not sure if we covered this, but I'm gonna be using the enumerate function, which will allow you to keep track of the number of iterations. So like the loops, like how many times it loops. It'll keep track of the number, so that way we can find the sum of it pretty easily. So I'll say digit, and in this is like the syntax to use the enumerate function. So enumerate and then ISBN. So we've defined that this is the ISBN. So I'm just gonna be putting ISBN here, and I will also mention the index here. So I'll have that curly brace, and inside I'll say like, yeah, like that. So that way we're gonna be checking for that index and like that. And next thing I'll do is I'll check for if it's not a digit. So like that's like the part where we talked about like the X and things like that. So if not, and then digit, and then I'll say if the digit, so if the number we have is a digit, so basically the is digit, like it suggests, is going to check if it is a digit. And if it's not a digit, then that will also return false in this case. So is digit, and sorry, and that will return false. And I'll then calculate the sum of it finally. So these are all just the conditions that lead up to the sum I'm going to be like that's like what I want to get. So since we started with the total as 0, then I'll just be adding up things on the total. So total, and then plus minus, and then I'm gonna have, so we said this is kind of like the variable, but that's like the digit variable. So I'm gonna say since it always has to be an integer, I will say int digit, and then I will multiply, and then next, I don't know why it keeps on saying, but 10 minus I. So in that way, I was basically, we were checking if, so we use the enumerate function to check for the number of iterations that happened. And since we have 10, so um, each time, so this is going to subtract the number of iterations, and that's going to multiply to the digits in order to get that sum. And after, so this is all the sums of the first 9, and then the last one, the 10th digit, that's what we'll be checking for next. So um I'll say I'll call this last. So last and then equals to ISBN, and then the index is gonna be, sorry, in square brackets -1. And after that, um we'll check for the like this test case, and the last digit was an X, so we'll be checking for that first. So I'll say if last is equal to string X, then I'll say total, and then I'll add 10. So the logic behind that is so this was so let me show you. Okay, so these first nine were what we calculated here. And then next we will be checking for this one, and we're looking for that in the case that this X is becomes the last digit, then we will be adding 10 from here. Um as this one suggests. And after that, if that's not the case, obviously, because X may or may not be the last variable or the last digit, and I'll say elif um if the last is a digit. So if that happens to be a number, then I'll say total, and we'll be adding that by last. So whatever is last here, then we'll obviously define that as an integer, since everything is supposed to be integer here. So int and then last. And if none of these are true, then lastly we have the else statement. And if none of these are true, then it has to be false. And this will not be true of any sort. Okay, so that I checked, this is like the step of where I'm checking for the last. And I considered the fact that it can also be an X, but it can also be a digit. And then the whatever is under here is what will be acted upon it if this either of these conditions are true. If not, then it'll return false. And lastly, we have to say, we have to take into account that it has to be divisible by 11, right? So we'll say we'll return true if it happens to be divisible by 11. So the way we're going to do that is return, and then if the sum, so we said it was total, so total. And we'll say to check that if it is divisible by 11, we'll be using the modulus operator, and we'll say 11. And after we divide by 11, then there has to be no remainders left, so that will be equal to 0. Okay, so that was all the conditions we've covered. And lastly, we need to get, or not lastly, but we need to get the standard input. So we'll just say uh we'll call it def, we'll just say main, so def main. And like that, and we'll call this the input, the n, and we'll be using the standard input, so int and then input, just like that. And next we'll be iterating through the number of cases. So these so far were all the like the conditionals, but we, in order to get the correct like answers, and in order to be able to test all the test cases correctly, we need to iterate through all the test cases we have. So for in range, and then we'll say n, and we'll say ISBN, and make sure that we take into account of um yeah, so like if this is given, there's like hyphens in between here, so we it will cause an error if a hyphen is in between there. So we just in case we do have a hyphen, then we'll be removing the hyphens. So the ISBN is what we're getting. So that's gonna be like what the program user, I guess, is going to be giving to us. So we'll say ISBN, and what I said, we'll just put that into code. So ISBN is going to be the input, and in any case that we do have a hyphen, then we'll use the replace, and we'll use the two strings. So hyphen, and then we'll just replace it with literally nothing. So we'll just have an empty string here. And that's going to remove all the hyphens in the ISBN. Okay. And let's continue iterating through our cases. So we'll say if, and then by the book, like we stated on the very top, by the book, and then ISBN. And if the ISBN is true, so if this returns as true, then we'll print valid. So that's kind of what the sample inputs and outputs wanted from us. So we'll say print and valid, and then always if there's a valid, then there has to be an invalid. So print invalid, invalid, just like that. Make sure it's all uppercase, because I think it'll cause an error if there is no up if you like put in lower cases, because that's what the output gave us, and it, I think, strictly needs to match like the even the upper and lower cases, like that. And lastly, we just need the command to run the program. So the way we're going to do that is if, and then name underscore, and then equals main. So that was our this over here. So that's the part where we're iterating through the cases. So we do need the main here. So underscore main, and then that's gonna print out the main, basically. And let me just clear the console, and let's try running this. So it did compile, thankfully, and we will put the test cases in, and we'll see how it does. Okay, yeah. So the first one came out as valid, second one invalid, and third one invalid or valid. And then yeah, so all the sample outputs were correct according to the inputs we put in. So let's download that as well, and we'll test it out in Uncode Quest. So okay, let's select the files. Where's it? Oh, main one. Okay, upload it, and judging in progress. Let's wait for a couple of seconds, and we'll reload this. Yeah, so the status did come out as solved, so we did do the problems correctly. Okay, next, the problem we'll be doing is caught speeding. So I think this is a little bit of a fun one, I think. So let's try this. Okay, so caught speeding basically is, let's wait for it to load. Oh, wow, okay. It's taking a while. Okay, so caught speeding is basically you were driving too fast, and the police officer saw that, and he pulled you over. And the police officer needs to determine how big your speeding ticket will be. And the police officer felt nice, I guess, and he decided that if it was your birthday, then he will let you go. So the problem description, so these are our variables that we need to consider for. So if my speed was 60 or less, then you don't get a ticket. And if your speed happens to be in between 61 and 80, so inclusive, meaning that 61 and 80 are included, then you just get a small ticket. And if your speed is 81 or higher, you get a big ticket. And today's your birthday, so all of these numbers are decreased by 5. So for example, if you drive like 70, let's say, if it is your birthday, then you only get a 65 ticket. And then the inputs will be positive integer that will represent your speed, and the word true or false, that will say true, meaning that today is your birthday, and false, meaning that it's not. And then the outputs will have no ticket, big ticket, and small ticket. Okay. So yeah, let's code that out. This so let me just clear this. Okay. So we have def, and then I'll name it by the problem number or problem name. So caught speeding, and we need to take account for the speed and birthday, like that. Okay, and I'll take into consideration of birthday first. So if it is your birthday, and remember, it said speed is increased by 5. So all these numbers are increased by 5. So you can drive up to 65. So um, this way we need to work backwards, since if it is your birthday, then the input will submit a number that will be already increased by 5. So in order to take into account of that, then we need to decrease the speed by 5. So speed, and then we'll say -5, like that. And next, we need to take into consideration of these conditions. So if your speed is 60 or less, then you don't get a ticket. Okay, so I'll call out speed as well. So if speed is less than, so is this inclusive? Oh yeah, so 60 or less. So 60 is included. So less than 60, then you don't get a ticket. Okay, so you say return. And then remember over here, this is like the syntax or like the way they want it. So just make sure you guys type that exactly. So no ticket. And next, you have the condition of if your speed is in between 61 and 80 inclusive, then you get only a small ticket. So make sure you take into consideration of the um, inclusive part. So else if, so elif 61 and then is inclusive, and then speed and then 80, then you only get a small ticket, like that. And then else, so whatever else, so if it's greater than 80, so we check for everything under 60 in between 61 and 80. And we don't need a separate condition for like if it's greater than 80, because whatever is rest of it will be greater than 80. So we'll can just say else and then return big ticket. That. Okay, so those are all the conditions that we needed to check for. And after we just need to read the input, and then we just need to print it out. So I'll say n equals int input, same as always. And I'll use the for loop to check for everything. So for in range, and then n. Then first one more thing before we take into consideration of speed and birthday. Remember that these test cases give you speed and birthday at the same time. So make sure if we're considering these, then we split these two so it is accurate. So first, before we print everything out, I'm going to use a split method to split these two. So birthday, and then I'll say input and then split. Okay. And afterwards, obvious just in case that the speed is given, or I don't think that the inputs here give you like a decimal, but just in case they do, for like other test cases, I'm going to use the integer method to make sure it is an integer, so int speed. Again, this is just a just in case kind of thing. The problem with the test cases we have, it doesn't really require it, but this is just a just in case like precaution, I guess. And I'll say birthday, and then if birthday is true, so if it is your birthday, so birthday is true, then in that case, we'll be printing what we got here. So print caught speeding, and then speed birthday, just like that. And then let me clear this console. And let's try running it. I think we've taken into consideration of everything. Yeah, so the true meaning today is your birthday, so we've checked for that. And yeah, that was the last thing we need to check for. Okay, so let's run that. It did compile. Let's get these test cases and run it. Okay, yeah, so 60, and without your birthday, that was no ticket. It's kind of wonky, but no ticket. And 82 and false. So if it's not your birthday and then you had it 82, then that's a big ticket. And then you drove an 83, but it was your birthday, so you could subtract that by 5. So that's what, 78. So that will give you a small ticket. So all these were true, I think. No ticket, yeah. So let's download and submit it into CoQuest. Okay. Alrighty. Oh, and it'll be, I think, main 2. Okay. Let's submit that. Judging in progress. Um, let's reload. Yeah, so status is solved. Perfect. Okay. Last question I'll be talking about um will be change for the world. So I think it is okay, here it is. Okay, so this is a money related thing, as you can see on the top. But basically the background is you're taking into consideration of coins, and you happen to be one of the people who really like the coins. And instead of paying with like exclusively in cold hard cash, you are paying with coins. So if you were to like pay your lunch with pennies, that's kind of ridiculous. So in this case here, it gives you a description of how much each coin is worth. So the quarters are worth 25 cents, dimes are worth 10 cents, nickels are worth 5 cents, and pennies are worth 1 cent. And if you have a bill of 41 cents, then you can pay it with 4 coins. So there's many ways you can do this. You can pay it with like 4 dimes and a penny, or you can use like quarters, a dime, and so on and so forth. So there are many ways you can do this, but we want to get the most efficient way to do this. Okay. So the sample input is the first line will be like your bill, I guess. They're saying, and each test case will have to you'll have to convert the dollar amount to coins, and so like how many of what, basically like that. And we'll start on a dollar sign, and then there will have two decimal places, sorry. And these are your test cases, and the sample output requires it to be in this certain format. So quarters equals X, dimes equals X, things like that. Okay, so let's take a moment to code this out. Okay, so the first thing I will do is, since I predict that there is a lot of math that's going to be taken into consideration, I'm going to import the math module here. So math, and after I will just do the same start. So change for the world, and then I'll name this amount. Okay, and the amount is, I will replace um the dots or the periods over here with just open spaces. So that's the first thing I'll be doing. So amount and equals int, and then I'll replace the very first one. Sorry, very first one. Uh, and then wherever there is a dot, so I don't really want the dot here since it will interfere with our calculations, because we are converting the coins into dollars, or no, sorry, the dollars into coins. So we don't want that period, or else it's gonna we're gonna be calculating with decimals. So we don't want that. So we'll first remove that, and afterwards we'll tell Python the values of each coin. So like the quarter equals 25, like things like that. So I don't know about you, but I don't really like typing, so I'll say Q for short for quarter. So quarter is amounts divided by 25. So notice that the problem said 25 cents, so 0.25, but we got rid of the period. So we just say 25 now since all the place values were moved. So Q equals or amount divided by 25, and then afterwards we'll define the amount and then we'll give it like the remaining value. So amount equals amount and then mod 25. And then we'll just do that for everything, all the place values. So I'll just copy and paste this 3 more times like that. And this will be dimes and that'll be 10 and then 10 here. And then quarters times and then nickels, that'll be just 5 here. And then that'll be 5. And then lastly, pennies will be equal to just um 1. But for pennies, since it is 1, we can just say pennies equals amount since even if so let's say I did this, okay? Um like that. This would work, but you want to ask how efficient is using 2 lines of code to say basically just penny equals amount because all you're doing is just dividing things by 1, but that would just be the same thing. So what I want to do here, I would just delete all this and I can say penny equals amount. And in this, I'll return all these. So return and then quarters, dimes, nickels, and pennies like that. Okay. And after that, uh, I'll create main. And inside here, I'll be so these were all our conditionals. And inside here, I'll be first um I'll start by saying n equals I'll call the standard inputs. So int input. All right. And inside, actually, I'm gonna use a strip method, which removes like multiple occurrences of a certain character, or like if there's like white spaces in between, then that the strip method actually gets rid of that for you. So there's other ways to do this, but I think this will be the shortest for me. So I'll use strip, which will get rid of like all the unnecessary like spaces and things like that. Okay. And for in range, and then n, and then after, I'll do the same thing for amount. So the strip thing, strip method, I mean. So amount input and then strip. Okay. And after that, I'll set, so I return these values, right? And I'll set those equal to amount. So that way, whatever we have here is going to be equal to amount. So that was kind of our main purpose, that we define all these and then we basically are just like shoving all of that things inside the amounts here. So in here I'll say q, d, and p, and we'll say change sorry, change for the world, and then I'll say amount. So all of these conditions were basically plugged into amount. And afterwards, we want to print these values. So I'm going to say print amount first. And after, um, all we need to do is basically just format everything according to like the output they want it in. So we are basically done, except we just need to format it correctly. So we'll be printing all of these except there's one. So um here, and then I'll say F, which will basically replace um the Q I put. So let me just show you what I'm gonna code out first. So quarters. So that's like the input they wanted it. And then these curly braces, what they're gonna do is they're basically gonna replace the Q value with the respective values. So when we calculate this here, so the amount is basically our inputs. So when the input is divided by like 25 and divided by 10, then all of these were basically stored inside the Q, D, and P. And that way, whatever value that it outputted for Q, for example, then it will be stored in here. That way, when we have like the number of quarters we need, then we will have the correct number of quarters. Okay. And we just need to do that exact same thing for everything else. So let me just copy and paste this. Oh, sorry. Okay. Um, Here, and then we'll say dimes, and then nickels, and then pennies, and then we'll just replace all of these with D, and then N, and then P. Okay. All right. And let me just check if I have everything here. Yeah. Okay. Looks good. And then after, we just need to print it out basically. So we just need to put the main like return the main. So if name equals main, sorry, underscore main. That way I just need print out main. Oh, return main basically. Oops, no, like that. Okay. And I don't know what this is doing, but yeah. So let's run it. So it did compile. So that's a good sign. And let's put all these test cases in here. Um, and let's see if we have the test cases we want. Okay, so wow, this is a long one, but let's see. 387. Yeah, so it roughly looks correct. Though I'm just skimming through it here, but yeah, it roughly does look correct. So let's download this as well and verify through CodeQuest that we did all these things correctly. Okay. So we'll go to the CodeQuest. I got logged out. Okay. Let me just log back in. And then change for the world, right? Okay. And we'll say submit, and um it was main 3, I think. Yeah. And we'll upload it, and then we'll see if we solved it correctly. All right, so judging in progress, and let me reload it. Yeah, so everything was solved correctly. So that's all for change for the world. So let me know if you have any more questions. But that's all for me. I'll be passing it on to Philip, who will be going over the next 4 solutions.
Um, Hello. I'll be going over the next four, and sorry, let me log into REPL. Uh, Sorry, it's kind of taking. Okay. Uh, all right. This is our uh. uh Sorry. Okay. All right. This is our question. This is our next problem, the anagram checker, and let's look at the description. Okay. So, an anagram is a type of wordplay, the result of rearranging the letters. So this problem is just going to look um at a word and see if the same words, same amount of letters, and same letters are inside the rearranged words. So when you rearranged stop to pots, that will work. If you rearrange admirer to married, that should work. Cat and dog well definitely doesn't work. And creative and reactive works and so on. So for this code we will uh, either say that it is an anagram or not an anagram. And so yeah, this should be pretty simple. Just looping through these words, and after you loop in through one of these sentences, check to see if when you rearrange, when you count the number of letters, then they will be the same. And so yeah, what you first want to do is first import this, then you could get n, which is the number of words over here. Sorry, um, forgot. Um, and, oh, and make sure to make it into integer because it always inputs string. And next, we want to just get these words. So we want to do a for loop. For it doesn't really matter. I in range it, and that is because we want to go through all of these words. That's the and n is the number of words. So now you have these two words here, pots and stop and pots, and you want to split them. And so what I would do is you could say uh like x and y is equal to, and you could do many different things. In my opinion, I think the map function would be the best. Um, and when you get the input, you split it so that it becomes stop and pots, and you want to split here with this vertical line. And so that you get x is pot a stop, and uh, y is pots. And so after you want to start comparing things. And so to do that, you could do like if x is equal to y, then print uh it's plus. So oh sorry, not case. You could do actually, because you need to rewrite this word later on the output, I'll just make this into one anagram. So I'll just create this. Then I'll just so this anagram will be like anagram is equal to stop. Um, so I'll just go from anagram 0 Uh, yeah. And for anagram, I don't think you really need to. Um, oh, actually, yeah, because I need to make separate ones. Anagram would be just the word itself, so it would just be the input itself. Because I need to reuse anagram, and I'll just use x and y is equal to pause and stop. So anagram will actually be just equal to stop and pause, and x and y will be equal to um, stop and y is pause. So one way I could do is again the map function, or I could just do the split function. I think here I would just do split, um, and it will just unpack these two. So we just do x y and print and then gram plus and and then else. Whoops, if the sorted x is equal to sorted y, then you could also print this case. Else, you could print it is not an integer. So sorry, what? Um, yeah. So what I did here was, um, if x is equal to y, so like of course if um in this um in this fun sorry in this example it says that it is this is not an anagram because because there are two same words and that doesn't make it an anagram because it needs to be a scrambled word. And so sorry, I made a mistake here. Not an anagram. It's and then else you want to see if the two words are not equal to each other, you want to check if when you sort one word and sort another word, and when you sort them alphabetically, and if they equal, then they must be an anagram because there's no other way that they can't be because that means they have the same amount of words and same amount of letters. Um, yeah, and else if nothing works, if they're just words like cat and dog, then it prints not an oops, not an anagram like this. So yeah, I made this file and sorry, no, I'm gonna download this file as main.py and let's try checking our answer. Run that password. All right, got it. Save it. Sure. Let's finally check it. Similar solution. See. Downloads. And upload solution. Changing progress. Oh, sorry. Might have made a small mistake somewhere. I'm not sure why I got this error. Let me try it. All right. So this worked before. Try taking out the maybe the phone. But sometimes it is the phone. Um, and, um, I try. Let's see. Let's copy this. Oh, sorry. I did not see that. Um, I didn't see that. I didn't hear this. Let me try it again. One. Stop. Mm, It's not an error. It should work now. Um, okay. It's one thing. Sorry. Mm, There you go. There was an integer, so it didn't print what I wanted to print. Right. Sometimes it's hard to keep up. Uh, I hope that this works. All right, it's solved. I'm very sorry for the, the debugging part, but yeah. This is the solution, and yeah, I think we could go on to the next question. Remember, if you have any questions, please ask them. And I think after we're gonna end, so I have to pass it on to.
Yeah. So that is all for today, guys. Hopefully you guys understood the competition problems, and if you didn't, make sure you guys are leaving questions in the Q&A. Um, and yeah, we will see you guys tomorrow, and have a good day. Bye, guys.